Hello and welcome to this presentation on iterators in Python. In this session, we will explore the concept of iterators, how they work, and how you can create custom iterators for your Python programs. Let's dive in. Let's start with an overview of iterators. An iterator is an object that allows you to traverse through all the elements in a collection, such as a list or a tuple. The key to an iterator is that it uses two methods underscore underscore iter underscore underscore to initialize the iterator and underscore underscore next underscore underscore to retrieve the next item in the sequence. Why should you use iterators? Well, they are great for efficient memory usage and simplify the process of iterating through large or even infinite datasets. Now let's look at the two main methods of an iterator. First, the iter method. This method initializes the iterator and returns the iterator object itself. It's required to make an object iterable. Next, we have the next method. This method returns the next item in the sequence. When there are no more items to return, it raises a stop iteration exception, signaling that the end of the iteration. Now let's see how can you create a custom iterator. Consider the following example where you can create an iterator that behaves like Python's built-in range function. In this example, we define the init method to initialize the start and end values, iter to start the iteration, and next to increment and return the next value. As you can see, custom iterators allow you to define your own sequence logic, making Python even more powerful for various use cases. Python provides built-in iterables like lists, tuples, strings, and dictionaries. You can easily convert these into iterators using the iter function. Once an iterable is converted into an iterator, you can use the next function to retrieve items one by one. Here's a simple example with a list. By calling iter on a list, you get an iterator, and using next, you can access the elements sequentially. One of the most common ways to use iterators is with a for loop. The for loop automatically handles the iteration process by calling iter and next behind the scenes. With this, you can loop through all the elements in a collection without manually managing the iteration. This makes your code cleaner and more readable. An important concept when working with iterators is the stop iteration exception. This exception is raised when there are no more items left to return in the iterator. You can handle this exception in your code to gracefully handle the end of the iteration. For example, you might use a try block to catch the exception and output a message when the iteration ends. Now let's look at some exercises to practice what we have learned. First, try creating a custom iterator for generating the Fibonacci sequence. Then explore how you can create an infinite iterator that generates numbers indefinitely. Another exercise is to build an iterator that reads a file line by line. Finally, try using zip to combine multiple iterators into a single iterator. To summarize, iterators are a powerful feature in Python that provide an efficient way to traverse through data. We have seen how iterators work, how to create custom iterators, and how to use built-in iterables with for loops. Understanding iterators can help you write cleaner, more memory efficient code, especially when dealing with large datasets. Thank you for joining this session, and I hope you now feel more confident working with iterators in Python.